Hi, in this class we will understand the explanation of graphs of quadratic equation. This lesson will cover the expression of graph of the quadratic equation. Okay, now let's proceed forward. Before proceeding, let's have few things in our mind. Is what is the general equation of a graph? The general equation of a graph is ax square plus bx plus c. Yes, and what is d? D is known as the discriminant of a graph. What does discriminant helps us to do? It helps us to tell how many roots will be for a particular quadratic equation. Okay. One thing that we should always keep in mind is that if the equation is quadratic in nature, the graph of that particular equation will be a parabola. What type of parabola? That depends upon the type of equation. So in now we will look into what are the different types of parabola for different types of equation and how we will able to determine from an equation how will the graph look like. So if in the particular equation, if the in the equation if a is greater than 0, then it will be a upward facing parabola. Okay. Now, and if it is d is greater than 0 for that particular equation, it indicates that there are more than one roots. So here you can see this in this graph, there are two roots, alpha and beta. What are roots? Roots are the position where the graph intersects the x-axis, or you can say at that point of the graph where the y coordinate is 0. Okay. Now, in this particular graph, what you can look that from the all the points in the graph from b to positive infinity are all above the x-axis, or you can say the y value for all the points from beta to plus infinity is positive. Same goes for all the points from minus infinity to alpha. All the points lie on the above the x-axis, or you can say on the positive part of the y-axis. So for that reason, you can see the range of this particular value is greater for the graph is greater than the value of the particular points is greater than 0 for all the points between alpha to infinity and minus infinity to beta. You can see here, and you can see all the points between alpha to beta are lying below the x-axis, or you can say the y value for all these points will be negative. So ax square plus bx plus c is less than 0 for all the points between alpha to beta. Yes, and also you can see that there are two also the roots of the equation are real and distinct. What does real indicates? They lie on the x-axis, and what does distinct indicate? They are two different roots. Now let's go into the next type of graph, which is if in the particular equation, if the a is greater than 0, then we know it is a upward facing parabola. Then if the d is equal to 0, it indicates that there is only one root, or you can say one root is being repeated twice. So two roots both are having same value. So that's why it is called the roots are coincident. Yes. Now let's look into the range and the output. So you can see all the part of the graph is lying on the positive part of the y-axis, or you can say above the x-axis, except one point, which is the minimum point of the parabola. Yes, that point coordinates are minus b by 2a and b by 4a. So this is the coordinate. The x coordinate is minus b by 2a and the y coordinate is minus b by 4a. So this is the lowest point of the parabola. Yes, you can see all the points are on the positive part except this particular point. This lies on the x-axis, or you can say it has only two roots which are being present at one position. So that's why you can see that ax square plus bx plus c is greater than 0 for all x except alpha, or you can say this particular point. Or I can say that ax square plus bx plus c is equals to 0 because for this particular x value, the y coordinate is 0. Yes, so x equals to alpha is equals to beta because both roots are present at one position. Now, let's have to look into the third type of graph. Third type of graph is where a is greater than 0 plus b is less than 0. Since a is greater than 0, we know it will be an upward facing parabola. And if d is less than 0, indicates that there are no real roots, indicating this graph doesn't touch or divides the x-axis. So you can see that this part of the graph is well above the x-axis. It is not touching the x-axis. That's why no roots. So here the roots are what? Complex conjugate. So if there are no real roots, then there will be a complex roots. That is the equation. Also, you can see that from all the points in the graph, the y value is positive. So that's why ax square plus bx plus c is greater than 0 for all x value because the graph is always in the positive y-axis. Next, go to the next type of graph where the a is less than 0 and d is greater than 0. Since a is less than 0, we know it will be a downward facing graph. And since d is greater than 0, indicates that there are more than one rows. So you can see there are two roots. One is alpha and another one is beta. Also in this particular graph, what we can see that all the points between alpha to beta are lying above the y-axis. Yes, so that's why ax square plus bx plus c is greater than 0 for all the points between alpha to beta. And what are the remaining points? Minus infinity to alpha and from beta to infinity. All those remaining points will lie below the x-axis. So that's why ax square plus bx plus c is less than 0 for minus infinity to alpha and from beta to infinity, union of beta to infinity. Clear? Now let's go to the next figure. In this next figure, what is happening? Here a is less than 0 and b is equal to 0. A less than 0 indicates it will be a downward facing parabola, and b equals to 0 indicates that there will be a perfect square, or one there will be only one root which will be repeated. So that's why it is written here the roots are coincident. Means both roots are lying at the same point. So in this particular graph, what you can see that a whole part of the graph is lying below the x-axis or called negative y-axis. So except one particular point, which is the maximum point of this graph, or you can say minus b by 2a or minus b by 4a, which is the root of this particular equation. It is that part of the, it is only one point where the graph is intersecting the x-axis. So for that's why it is written ax square plus bx plus c is less than 0 for all values except alpha, which is the root. Yes, and ax square plus bx plus c is equals to 0 for x equals to alpha. And also since every quadratic equation has two roots, so here alpha is equals to beta because both roots are lying at the same position. Now, what is the final type of graph where a is greater than 0 and d is less than 0? Yes, so if a is less than 0, we know it will be a downward facing parabola, and d less than 0 indicates that there are no real roots. So that's why it is not intersecting the x-axis. It is below some distance of the x-axis. So that's why if there are no real roots, that means there will be complex conjugate roots. Yes, because complex root forms in pair. That's why the roots are complex conjugate. Yes, so all the values you can see for all the values of x, the graph lies below the y, you can say x-axis. So for that reason, ax square plus bx plus c is less than 0 for all the values of x. Yes, you can see this is the explanations that I have given and written here uh, point wise. If a is greater than 0, the mouth of the parabola opens upward or upward facing parabola. This shape resembles a curve that can feel like the water or look like the union sign, or it is explaining like this. This is the upward facing. Here you can see what we have given is that from intersect at 2 points x equals x1 and x equals to x2. These are the zeros of the parabola. Yes, if we go back to the first figure, you can see this is the alpha and this is the beta. All the points between alpha to beta are less negative y-axis, and all the points from minus infinity to alpha and from beta to infinity are positive y-axis. Yes, that is what it is written here. Next, for figure 2 as well, the curve touches the x-axis indicating both zeros of the polynomial coincide. This is for the equation where d is equals to 0 and y is non-negative for all x in the R. Yes, here also the a is greater than 0 indicating the same thing. Now, for the figures 4 to 6, we saw that the a is less than 0 indicating it is a downward facing parabola. Yes, the shapes look like a cup spilling water or the other like the intersection sign. Yes, okay. Now with the notes. So what are the notes? The condition for which quadratic equation y equal to ax square plus bx plus c is always positive is a greater than 0 and b less than 0. So d less than 0 indicate what? That it will never touch the x-axis, and a indicates that it will be a upward facing parabola. That means it will look something like this. Yes, it is upward facing, not, and it is not touching the x-axis. That is why it is always greater than 0. You can say this is always positive because it is never on the negative side of the y-axis. Same goes for here. Condition for this correct equation y equal to x square plus bx plus c is always negative is a less than 0. So if a less than 0, it will be a downward facing parabola, and d less than 0, that it is not touching the x-axis. That's why you can see this particular, all the output of this particular graph lying on the negative part of the y-axis. It's always negative. Next, the quadratic equation ax square plus bx plus c is a perfect square if a is greater than 0 and d equals to 0. Yes, d equals to 0 indicates that there is a perfect square. So you can see if this is a quadratic equation, it can be resolved into x minus 1 whole square. But the other equation, which is 2x minus x square minus 1, cannot be written in form of a whole perfect square. That's why it will have different roots. But this equation x minus 1 whole square means it has only one root, which is x equals to 1. One root is being repeated twice. That's why it is having the power of 2. Correct? Now, let's look into here. If a is less than 0, that means it will be what? It will be a downward facing parabola. If it is a downward facing parabola, then it means it will have the maximum value at certain point. So that point, x coordinate is minus b by 2a and y coordinate is minus d by 4a. Clear? Next, let's practice together few questions. One question is, if ax square plus bx plus 10 doesn't have any real and distinct rules. That means d is less than 0 for this. It doesn't have any real and distinct rules. Find the minimum value of the 5a minus b. So if it is doesn't lie in the particular, either it will be look something like this or look something like this. So if we find out, if we take one point and find out that yes, if this point is below the above the x-axis, that means all the point will lie above the x-axis. If one point is below the you can say x-axis, all the points will lie below the x-axis. So that's why what we will do, we try to find out the value for this equation for x equals to 0. So if you put x equal to 0, this equation will be 0, this equation will be 0, the output will be 10. So for f of 0, the output is 10. Since the output is positive, that means for x equal to 0, this point is what? Lying on the above the x-axis. That means this is the graph. Either this can be graph or this can be. But since one point is lying here, that means this is not the graph and this is the graph. So that is why we have written f of x greater than 0 for all x equals to I. Because you can see for all x value, this graph is above the x-axis. Now, what is the question asked us? Find the minimum value of the 5a minus b. So in this upward facing parabola, what is the minimum point that you can get if you put for minimum value of 5a minus b? So if we put f equals to minus 5 in the equation, how much it will become? 5. If we try to write it down, it will be minus 5 whole square into a minus 5 into b plus 10. And if we solve it, it will become 5a minus b greater than equals to minus 2. So what does this mean? It indicates that the minimum value of this equation 5a minus b will be minus 2. I hope this was clear. Yes. Now let's go to the next question. So for what values of k is inequality x square minus k minus 3x minus k plus 6 is greater than equals to 0? Valid for all real x. So from the equation, one thing that we know is a is greater than 0. Yes, so you can see here a is 1. What is b here? B here is this total value b and this total value is our c. So one thing that we know is that if a is greater than 0, that means it will be an upward facing parabola. And what do we want? We want all the values should be what? You can see it is given valid for all real x. It should be greater than 0. So if a is greater than 0 and the graph will look something like this, what do we know? That means the d should be less than 0, indicating it doesn't intersect the x-axis. So we need to find out for which value the d is less than 0. What is the formula for d? D is discriminant, which is can be given by b square minus 4ac. That is the formula for d. Now, if we write it down here, what we can see, our b here is how much? Minus of k minus 3 whole square, which is equals to k minus 3 whole square, and minus of 4 and minus k plus 6 is our c, and a is our minus plus 1, which is multiplied here. If we keep on solving the equation, we will get for k plus 3 into k minus 8 is less than 0. So for k equals to minus 3 comma 5, the within this particular range of values will be greater than 0. So for what values of k is the inequality valid for the real x? So for x, k equals to minus 3 comma 5. I hope this was clear.